For this problem, we want to find the key piece of information for this graph, and since this does have this key point right here, which is on the asymptote, that's how we know that this is going to be called an exponential equation. So it's an exponential because it has a horizontal asymptote. That's what you're looking for, and so we can just go ahead and jump straight to that since we just said it. An asymptote is a curve that is a line that your curve gets close to. So yes, this does have a horizontal asymptote. As far as a line of symmetry is concerned, no, there is no part that divides it into half. But yes, this is a function because if you were to pass a vertical line through it, it is only going to touch the graph at one particular spot. And so, yes, this is a function. And the name of the locator point here, actually, we don't have a real special name. We just call it locator point. There's no special aspect or special word we use for that particular point. That point in this case is at -3, +3. And so that's important for us as we write our equation. So you have an a, and we are always going to have a multiplier or a base of 2 to the x minus h and then plus k. That just keeps some things more simple for us. So since we know the locator point, we know that up top here you're going to have actually x plus 3, and then you're going to have another plus 3 down here, or outside of the exponential. And the exponential equation is kind of unique because right from that locator point itself, you can then draw a line to figure out exactly what your a value is. So you draw that line directly down, and that looks like it is going down 5 units. And so that is how we know what our a value is. It's a -5 out in front. So you look for your hk, which is at -3, +3. That's that locator point. A value is -5. Throw that into your equation.